So because it is a system of drainage of the waste products, interstitial fluid of the brain parenchyma, it's hugely important because every neurodegenerative disease that I'm working on and that I'm aware of actually has a component of deposition of a protein that we produce normally and is not eliminated efficiently. So the iPad system is extremely important. First of all, it's very vulnerable to external factors, to diet and the other metabolic risk factors and aging itself. And secondly, it's related, so it will fail at one point or another in an individual's life. The question is, how do we detect when it's failing before the onset of symptoms? Now, looking at post-mortem human brains, there are signs that it's failing 10, 20 years before the onset of symptoms. That's what we need to determine. That's one thing. The other thing is we have to be very mindful of this system when in therapies such as immunotherapy against the proteins that are produced in the brain itself. So for the last 20 years or so, there have been enormous efforts towards immunotherapy against amyloid beta. And we know from work in Southampton that immunizing against the protein produced in the brain will form immune complexes. It may clear the plaques, but if the drainage system is already compromised, it will worsen conditions like cerebral amyloid angiopathy. So if we're going to continue with immunization efforts, these need to be started early while the integrity of the vessel wall is not affected, and therefore the vessel wall is healthy, so it can cope with the excess fluid and clearing the proteins that we're immunizing against.